Hello and welcome back to Farmyard Academy. So we've got another video here for you today, looking at mole calculations at GCSE. They're probably going to be the more difficult ones on your papers. So we're just going to break it down. What I suggest you do is I suggest you pause the video, go through the calculation, see what you get, and then compare your answer with the working out. Okay, so first things first, what we're going to do is we need to know some information. So at the top of our questions, we're going to write down some mole formulas that we've learned. We're going to learn the one for a solid, which is N equals mass over mR. We're going to learn the one for a liquid, which is N equals CV. And we're also going to learn the one for a gas, which is N equals V over 24. And we're going to use one of these that we need to use. Then we're going to go through the question, and I always suggest that you highlight key points. So you've got here, it says calculate the mass of calcium carbonate. So if we highlight that, and then we go to the equation and we say, well, which one is calcium carbonate? And this is where it's layered, so you need to know what the carbonate ion looks like, and that's CO3. So if you go to our equation, there is our calcium carbonate. You go through to the question, and then another highlighter, it says 2 grams of calcium oxide, and you do exactly the same thing. So calcium and oxide, that means oxygen, and the only substance in the equation that's got calcium and oxygen on its own is this one. So those are the two substances. Then what you're going to do is you're going to write your own equation from the question, and because the question says calculate the mass of calcium carbonate, that's what we're going to need. So the only equation we can use for this one is the solid form, which has got mass in, which is this one, and we rearrange this to make mass the subject. Now, as it stands at the moment, you've got mR divided by mass divided by mR, and so in order to get the mR onto the other side of the equation, you just need to remember this, which is the word opposites. Okay, whatever it does on one side of the equation, in order to get it over to the other side, it has to do the opposite. So if mR is being divided, in order to get it over to this side of the equation, you have to multiply it. So that means that mass would equal N times mR. Okay, so this is the mass of calcium carbonate that we're trying to figure out. Okay, and then we just fill in our terms. We've got the number of moles of calcium carbonate. So we go through the question, have we been given the moles of calcium carbonate? We haven't, so we put a question mark here. And then we've got to work out the MR of calcium carbonate, and lots of different ways to learn this, but really the simplest way is just to know that the MR is the big number on the periodic table. So you just take your values and you find calcium on the periodic table. It should be 40. More accurate is 40.1, which is what I'm going to use. You've got carbon, which is 12. That's its big number. And then oxygen is 16, and you've got 3 of them. So it's 16 times 3, and that's what you've got there. Now if you do that, you've got 100.1. So if you do that, work that out, it equals 100.1. Okay, and you might get a mark for doing that. All right, so we haven't got the number of moles of calcium carbonate, so that's why we move on to stage 2, which is to work out the moles of something. And we work out the moles of something that we've got information for. Now we could be using the liquid formula, we could be using the gas formula, but again we go back to the question, and the bit that's highlighted in green, it says 2 grams of calcium oxide. Grams is a mass, so again we have to use our N equals mass over mR. So number of moles of calcium oxide equals mass divided by mR. Okay, so the mass of the calcium oxide is 2 grams. Okay, and the mR of calcium oxide, again big numbers, is 40 plus 16. Okay, so because oxygen's big number is 16, so overall that would be 2 divided by 56, which will get you the moles of the calcium oxide. Okay, right, we'll just call that X because you can work that out. And then stage 3 is to do a mole ratio, and all the mole ratio is the big numbers in front of the substances. So at the moment, if we look at our formula, we've actually got no numbers in front of calcium oxide. So there's no number here, there's no number in front of calcium oxide, and there's no number in front of the carbon dioxide. So no number in front of the calcium carbonate, none in front of the CaO, and none in front of the CO2. So what that really means is there's a 1 in front of it, because we don't really write that in. So it's a 1, 1, 1 ratio. So in terms of a ratio between the yellow one and the green one, it's a 1-to-1. So we don't have to do anything to the number of moles of this, whatever this comes out as. All we've got to do is plug that into our equation and multiply it by 100.1, and you've got your answer. Okay, so that's how you do it. Hopefully you've got on okay. Again, break it down in 3 stages, write the question out, work out the moles of something, use a mole ratio, and that hopefully should help. Okay, see you on the next one.